Today we're doing section 2.2 quadratic functions, and this is the third day in this section. So today we're going to be doing some word problems, so I suggest you pause the video and copy down this picture. Some vocabulary you're going to see is the terminology of max height, distance the object traveled down the field, and the point of impact. So when they say max height, they're referring to the y part of the vertex of our vertex. If they say how far from the point of impact does this occur, we're talking about the x part of our vertex. And if they say how far the distance the object traveled, we're referring to our x-intercepts. So we're assuming the object traveled up and then landed on the ground, so that would be an x-intercept. If I wanted to find any given height that corresponds to the distance, I evaluate the function at that distance, and then that would give me its matching height. So here's our problem. I didn't attach the picture with it, but it says a football is kicked to the nearest defensive player 6 feet from the point of impact with the kicker's foot. The height of the punted football f of x in feet can be modeled below, where x is the ball's horizontal distance in feet from the point of impact with the kicker's foot. So letter A says, what is the maximum height of the punt and how far from the point of impact does this occur? So letter A, we need to find the vertex, and this is something we did in class yesterday. So we know we do negative b over 2a. So I'll have negative 1.18 divided by 2 times negative 0.01. And when you do this calculation, we get 59 feet. So this is the distance it traveled down the field. Now to find the actual height at 59 feet, I have to evaluate it, so I plug it in. So I have to do negative 0.01 times 59 squared plus 1.18 times 59 plus 2. And this equals 36.81 feet. So the 36 is our max height, and the 59 is the distance it traveled from the point of impact. So letter B says, how far must the nearest defensive player, who is 6 feet from the kicker's point of impact, reach to block the punt? So if someone is standing 6 feet and I want to know the given height when it's 6 feet, I would plug it in. So for letter B, I need to evaluate the function at 6. So this means I'm doing negative 0.016 squared plus 1.18 times 6 plus 2. So this equals 8.72 feet. So the ball, that means 6 feet from the kicker, the ball is 8.72 feet. Now, the kicker, who is 6 feet tall, is not going to have to reach an additional 8 feet. They're only going to have to reach 2.72 feet to reach the ball. Or to block the ball, I should say. Okay, so now we're going to move on to letter C and D. So letter C says, if the ball is not blocked by the defensive player, how far down the field will it go before hitting the ground? So we're saying, okay, here's the blocker. It's not blocked. It goes, and now it hits the ground. So we're talking about an x-intercept. So I need to set the function equal to 0. And again, we've talked about how to solve equations like this the past couple of days. And we know if it's not factorable that we need to use the quadratic formula. So we're going to have negative 1.18 plus or minus 1.18 squared minus 4 times the negative 0.01 times 2 all over 2 times negative 0.01. And just like I always tell you, we find the value underneath our square root first. So I have negative 1.18 plus or minus, and when you calculate all that, we get 1.4724 all over negative 0.02. And then we would, I'll show you how to do this in the calculator tomorrow, but once we type in the two answers, we get, final answers are negative 1.7 or 119.7. And since we're talking about a real world problem, that we would toss out the negative answer and we would take the positive answer. So that means it traveled 119.7 feet down the field. And we're going to skip letter D for right now. It says graph the function, so we're not going to worry about that. Again, we'll do some practice of this tomorrow. So the next thing I want to show you is the second type of word problems, and we might be working on the next type of word problems for a few days. They're a little bit more involved. So the strategy for these, step one, is to read the problem carefully and decide what quantities. I always recommend that you write that equation of whatever needs to be maximized or minimized. So you're going to write an equation on the information that's given, and then you're going to write a second equation on what is actually trying to be maximized or minimized. So based on the information, you'll be able to write one equation. Then we're going to solve that first equation that we write for x, and then we're going to substitute it in. So I think instead of kind of following all this, I'm just going to dive right into a problem, and then we'll kind of go back and talk about the process. So it says, among all pairs of numbers whose difference is 10, find a pair whose product is small as possible. What is the minimum product? So what we're trying to minimize is a product. And based on the first statement, it says, among all pairs of numbers whose difference is 10. So the first equation that we can write is x plus y equals 10. So based on the information that's given. What I'm trying to maximize is the product, and a product means multiplication. So I'm going to take the equation that I was given, and sorry I said solve for x a moment ago. You should actually solve for y. So I'm going to subtract x over, and I'm going to get the statement y equals 10 minus x. Now I'm going to go to this second equation that I figured out what needs to be maximized, and I'm going to replace y with what it's equal to. And now I'm going to distribute. And last thing I would say is put it in standard form. And I know that whenever something says minimum or maximum, that's referring to the vertex. So now we're going to calculate the vertex. So x equals negative 10 over 2 times negative 1, which is negative 10 divided by negative 2, which is 5. And now that I know x, I need to find y. And notice that we have this nice equation right here that has y already by itself. So I say y equals 10 minus 5, which is 5. So I found x, I found y, and remember the ultimate goal is to find the minimum product. So I'm going to go back to this equation right here and say that my product is 5 times 5. So the minimum product would be 25. So we're going to pause with that. We'll do some more practice on that tomorrow, especially ones with area.